Hi everyone, this is Billy. I've been to Japan 2 weeks back and I visited a lot of places and ate some good food and also bought some crystal radio kits from Japan. This video I'll show you how I made it and the modification I did to the original circuit. I also put some of my pictures at the end of the video. Please watch till the end. If you like this type of video, please click like, subscribe, share with your friends. And don't forget to click the bell so the next time I have a new video, you'll be updated. Thank you. This is the shop I visited in Fukuoka, Japan. I'll put the link in the description so you can take a look when you are close by. The list of components there are huge, including some components that are quite antique, like this type of telephone sets, and also the crystal radio sets. This is the one that I finally purchased. This is the demo set. It's mounted on a piece of wood and a bottle. This is the description of the circuit and other things in Japanese. Let's open up the kit to see what's inside. Got an instruction. It said because 1N60 is hard to find, we're now replacing it with 090R. This is the original wiring diagram. It's very simple. Just a bottle and some coil and a variable capacitor. And this is the circuit diagram. To improve selectivity, I added the antenna coil, which will loosely coupled with the original resonance coil. I also added some tabs to the resonance coil so we can now select the impedance to match with that of the detector. Some magnet wire or laminated wire, I think this is around SWG 20 to 25. And then a bed full of components. Let's open that up. Crystal earbud. 1000 PF capacitor. It said here that it should be a 1N60, but since that is hard to find, it replaces with the OA90R. Plastic variable capacitor with 2 screws, 261. Let me explain to you the different parts of this crystal radio made from a Japanese crystal radio kit. First, we look at the body of the radio. Is made up of 2 plastic drinking bottles. I won a coil of 80 turns using the laminated wires or magnet wires provided by the kit. And then there's around 10 turns, one on another ring that I made of the plastics from the plastic bottle. So this ring is a little bit wider than the drinking bottle, so I can move it up and down. Where this coil, the antenna coil, can be loosely coupled with the resonance coil. So we can adjust the selectivity and sensitivity this way. In the resonance coil, I have created a few tapping points for the coil, around 20 turns each. And then all these tapping points are soldered onto this mounting board. So we got the ground here, the hot end of the antenna coil here, hot end of the resonance circuit, resonance coil here, and then the 3 different tabs in between. With this alligator clip, I can select to attach the detector to any one of the tabs. So we can have we can select the impedance to match that of our detector. So we can open up the bottle and see what's inside. We got a detector. It's the same detector 5-pin socket that I used in my other crystal radio projects. First 4 of these pins are for the MOSFET detector, the two gates, the source and the drain. And then the last pin is for the diode. Then you have the headphone jack. We connect a 200 kΩ resistor in parallel plus a 1000 PF capacitor in parallel. This will account for the use of both a magnetic coil type headphone or a ceramic capacitive type headphone. Then you have this 270 PF variable capacitor that comes with the kit, and this steering wheel, tuning wheel. I use the M4 screws to mount these terminals. For the two antenna tapping points and the ground, there's the additional antenna point at the top where you can mount a telescopic antenna at the top, so it will be useful when you are standing in a place with a strong signal field strength, like close to the transmitter. You can tune to the radio by just using this telescopic antenna. First, we'll find two drinking bottles. One of them should be slightly bigger than the other one. This small one will be used to wind this coil. The bigger one will be used to wind the antenna coil, which we can then alter the separation between the primary coil, the antenna coil, and the resonance coil. So we can tune the selectivity that way. So let's do some cutting. We have to cut this part as well, so you can hang on to this one. Okay. Then we made a handle using the other pieces, so we can wind the coil in the gap there. Let's fix it by using the staple. Next, let's mount the variable capacitor. To wind the coil, we need to pinch some holes 6 cm apart. The wires will easily get messy and tangled, so let's put it onto another bottle. Now let's start winding in one direction 80 turns. When that is done, let's solder the two ends of the wires and test the inductance. It should be around 330 to 360 microhenry. Now we got 347, pretty good. Let's mount the antenna wiring frame onto the bottle and start wiring in the same direction around 10 turns. We'll solder the hot end, cold end, and all the tapping points in between in the coil to this wiring board. Then you can use alligator clip to select which tap you want to go for. We'll be using some screws to secure the bottom of the radio with the top of the radio. So let's punch some holes and mount the screws to test. We will be using M4 screws as the antenna terminals. So let's punch some holes. The one on the cap of the bottle will also be useful to connect to the telescopic antenna. So when you stand in a place of strong field strength, you can just use the telescopic antenna as your main antenna and still be able to receive some signal. Let's solder the 200K resistor and the 1000 PF capacitor in parallel with the headphone jack. Get a 5-pin socket and put in the wires in the same color as I shown here. We can now start the interesting job of soldering according to the circuit diagram. Once it's completed, we can go to a place where we can hang a long antenna for the testing. like in the country park or like myself, next to the beach of Hong Kong. I will usually run an antenna of 15 meter long. I will also punch in this steel rod into the ground as my earth terminal. Now let's start the testing. I'm using this variable inductor or variometer as the antenna tuner. The antenna tuner is needed when you have a long antenna like in this case, so you can precondition the frequency range of the station you are going to receive. You can focus on a particular range. This is the end of the testing. Now I'll start showing you the rest of the pictures I've taken from the Japan Fukuoka tour. Thanks for watching.